We're going to continue our study of trigonometric functions with right triangles. In this example, we're told that the tangent of theta equals 3, and we're asked to sketch a triangle, find the third side, and find the other 5 trig functions. So we have a triangle here with a base of 1, a height of 3, and angle theta. In order to find the hypotenuse, we're going to use the Pythagorean theorem. So we know that the hypotenuse, or the radius, is r squared equals x squared, or 1 squared, plus y squared, or 3 squared. So we have r squared equals 1 plus 9, r squared therefore equals 10. In order to find r, we take the square root of both sides, and we get r equals the square root of 10. So the hypotenuse is the square root of 10. We can now find all of our trigonometric functions. We'll start with the sine of theta, which we know is equal to the opposite side, 3, over the hypotenuse, the square root of 10. In order to rationalize the denominator, we're going to multiply the numerator and the denominator by the square root of 10. In doing so, we get 3 times the square root of 10 over 10. The cosecant is the hypotenuse, square root of 10, over the opposite side, 3. The cosine of theta is our adjacent side, 1, over the hypotenuse, square root of 10. Again, we're going to rationalize the denominator by multiplying the numerator and denominator by the square root of 10. In doing so, we get the square root of 10 over 10. The secant of theta is equal to the hypotenuse, square root of 10, over the adjacent side, 1, or simply the square root of 10. And finally, the tangent of theta equals the opposite side, 3, over the adjacent side, 1, simplifying to 3. We're also told this in the problem. The cotangent of angle theta is the adjacent side 1 over the opposite side 3, or 1/3. Go ahead and pause the video now and try this problem on your own. So we're told that the cosine of theta equals 3 over 7, and we're asked to sketch a triangle, find the third side of the triangle, and find the other 5 trig functions. So, and given the cosine of theta equals 3 over 7, we're going to label our triangle with angle theta, and the adjacent side is 3, and the hypotenuse is 7, because the cosine of theta equals the adjacent side over the hypotenuse. Now we need to find the length of this side of the triangle, y. So we're going to use the Pythagorean theorem, r squared equals x squared plus y squared. And we know that r equals 7, which is the hypotenuse. So 7 squared equals x squared, and x equals 3, so 3 squared, plus y squared. 7 squared is 49, 3 squared is 9, plus y squared. So subtract 9 from both sides, we get 40 equals y squared. Now we're going to take the square root of both sides in order to solve for y. So y equals the square root of 40, but we can simplify that further. The square root of 40 is equal to the square root of 4 times 10. And the square root of 4 is equal to 2. So we can say the square root of 4 times 10 equals 2 times the square root of 10. So we've now solved for y, which is 2 times the square root of 10. Now we have all 3 sides of our triangle, and we can find our 6 trigonometric functions. We'll start with the sine of theta equals the opposite side, 2 times the square root of 10, over the hypotenuse, 7. The cosecant of theta equals our hypotenuse, 7, over the opposite side, 2 times the square root of 10. We're going to rationalize the denominator by multiplying both the top and bottom by the square root of 10, and we get 7 times the square root of 10 over 2 times the square root of 10 times the square root of 10, which is 10, so that's 20. Next, we're going to solve for the cosine of theta. Even though we're given this in the problem, let's just check to make sure it works. So the adjacent side 3 over the hypotenuse 7. The secant of theta equals our hypotenuse 7 over the adjacent side 3. The tangent of theta equals the opposite side, 2 times the square root of 10 over the adjacent side 3. And finally, the cotangent of theta equals our adjacent side 3 over the opposite side, 2 times the square root of 10. Again, we're going to rationalize the denominator, 3 times the square root of 10 over 20.